We're going to sketch the graph of the polar equation r equals to f of theta is equal to 2 times cosine of theta. First, we want to know if we can express this polar equation as an equation in Cartesian coordinates that we can recognize and sketch. We multiply both sides by r. We end up with the left hand side equal to r squared, the right hand side equal to 2r cosine of theta. Recall that in Cartesian coordinates r squared is equivalent to x squared plus y squared. R cosine theta is x, so the right hand side is 2x, and this is x squared minus 2x plus y squared equals to 0. Let's complete the square in variable x by adding 1 to each side. X squared minus 2x plus 1 plus y squared is equal to 0 plus 1, which is 1. So x minus 1 squared plus y squared equals 1. And this is a circle with center 1, 0 and radius 1. Let's make a sketch of this circle in the xy plane. Now, using polar notation, the x-axis is the line theta equals 0. The y-axis is the line theta is equal to pi over 2. And this is the graph of the circle. And this is the center 1, 0. This is 2, 0. This is 0 minus 1. And this point here is 0, 1. So r equals 2 cosine of theta is equivalent to x minus 1 squared plus y squared equals 1, and this is its graph. Now, the second way we're going to do it is to graph it directly without changing it to rectangular coordinates, and that's because most polar equations can be changed to rectangular equations, but those rectangular equations are very difficult to graph in rectangular coordinates. So we're going to graph r equal to 2 times cosine of theta directly, and we want to check for symmetry. Symmetry is very useful when it comes to graphing polar equations. The first type of symmetry we'll check with respect to the polar axis. Polar axis is just the x-axis, or the line theta is equal to 0. So let's see when the graph will be symmetric with respect to the polar axis. It will be symmetric with respect to the polar axis when every point on the graph, so let this be a representative point on the graph. It has polar coordinates r and theta, and the point on the opposite side of the polar axis, or the opposite side of the x-axis, must also be on the graph, and that point will have coordinates r, but the angle is going in the clockwise direction, so it's going to be minus theta. Now, if r equals f of theta is the equation, if the polar equation, then replacing theta with minus theta and plugging that minus theta into the function will give us the same r. Whenever that happens, that's an indication that the graph is symmetric with respect to the polar axis. So our equation is r equals f of theta, and that's equal to 2 times cosine of theta. Let's check it to see if it is symmetric with respect to the polar axis. We're going to plug in minus theta for theta. F of minus theta is equal to 2 times cosine of minus theta, but recall cosine is an even function, so cosine of minus theta is equal to cosine of theta. This is equal to 2 times cosine of theta. Nothing has changed, and of course that's f of theta. And we just showed that the graph, the polar equation r equals to 2 cosine of theta, is symmetric with respect to the polar axis. What that means is we just need to get half of the graph. That is, once we have half, we're going to reflect it or fold it about the polar axis, and we'll get the other half. So let's make a table of values of theta, let's say in the first and the second quadrant. This is theta, this is r. Recall that r, of course, is equal to 2 times cosine of theta. So we'll start with theta equal to 0, then we'll go to pi over 6, pi over 4, pi over 3, and then pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and then pi. It's very important that you practice with the unit circle and know basic values of sine and cosine at these angles. So here we'll make our chart. Try to make that as big as possible so that it'll be easier to graph. So this is the x-axis, theta equals to 0, and this is the y-axis, theta is equal to pi over 2. Let's make the angles. This would be our pi over 6, pi over 4, pi over 3, and this would be 2 pi over 3, and then 3 pi over 4, and 5 pi over 6. Let's plug these in at 0. Cosine of 0 is 1, so the value of r is 2. So let's plug that over here. Let's say this is 2. Cosine of pi over 6 is square root of 3 over 2 times 2, that's square root of 3. At pi over 4, cosine is square root of 2 over 2 times 2, that's square root of 2. Cosine of pi over 3 is 1/2 times 2, that's 1. Cosine of pi over 2 is 0. Let's plot these. At pi over 6, we have square root of 3, which is smaller than 2. At pi over 4, we have square root of 2. At pi over 3, we have 1. And at pi over 2, we have 0. So what we have between 0 and pi over 2, we're tracing out this part of our graph. Being that it is symmetric with respect to the polar axis, we get exactly the same thing on the opposite side of the polar axis, or the x-axis, and that's what we have. We also get the direction with which the graph is traced from small values of theta to larger, and this is the direction. We can draw an arrow like this pointing in the direction of the flow. Now let's go to the second quadrant and see if we can generate anything that we don't already have. At 2 pi over 3, cosine of 2 pi over 3 is minus 1/2 times 2, that's minus 1. So when we're facing in the direction of angle being 2 pi over 3, r is negative. We go in the opposite direction, and that lands us right over here on the lower semicircle. That's the part we already have because of symmetry. Similarly, cosine of 3 pi over 4 is minus square root of 2 over 2 times 2. That's minus square root of 2, and that again puts us in the opposite direction to the angle, puts us right over here. At 5 pi over 6, cosine is minus square root of 3 divided by 2 times 2. That's minus square root of 3. Again, that gives us this point over here. And then at pi, cosine of pi is minus 1, and then times 2, that gives us minus 2. And that, facing in the negative x direction, r being minus 2, we go in the opposite direction, which is this point. This is the graph using symmetry. So r equals to 2 times cosine of theta is again a circle with the center 1, 0 and radius 1. And very important that we trace this circle. The circle can be traced completely for values of theta between 0 and pi. Not 2 pi, but pi. If you look at this table, once we move from 0 to pi, we generate the entire circle. And if we go from pi to 2 pi, all we're going to do is retrace this circle once again. So in the problems that are going to come later, when we have to compute the length of polar curves and also the area of polar regions, very important to know what values of theta, what interval generates the polar graph. And in this case, the interval is from 0 to pi. For more videos, visit www.mathprepvideos.com.